Just want to say a couple things about the space before we get started. This is where I work. It's really cool. And we can use the space pretty much whenever we want for whatever we want, uh, as long as I'm here. If we want to do it, you just have to convince me that I should stay here, and 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 then we can do it. So if we want to do things like, you know, uh, atypical meetup things like just getting together and coding in Haskell, we can do that, and any sort of thing. So if you have any ideas, like just send them to me in an email on Meetup or whatever. Just talk to me after, and we'll make it happen. Um, Also, we are hiring, and it's really cool. We do a lot of FP here. It's in Scala. We're not doing any Haskell. I'm working on that a little bit, but um, I don't see it happening soon. But we still like we can write Scala as FP style as we want. So it's fun. And so that's all. Now I'll let Julian get started.
Yeah, does anyone, if anyone wants to announce anything, please go. Yeah. I will be using it. Yep. Hey, so I kind of want to actually do this in a way where people are involved and ask questions. And it would be best if people understood things. And so, and for that, it'd be great if I had a sense for where everyone is, or at least most people are. How many of you have written, say, 1,000 lines or more of Haskell? Okay, cool, awesome. Used Haskell web frameworks before? Okay. Played around with Servant? Okay, great. This will be great. So the basic idea of Servant is that when we're writing web applications, we very often end up encoding the same information in very many different locations in our code. So can everyone see this? Yeah. No? Okay. So this is pseudocode that I'll write. Never mind the imports for now. So when you're writing a client, you might have, or when you're writing a web application, you might have my web equals, I don't know. Again, I'm making this up as I go along. This isn't a real web framework, but get path, and then some do, and then I might sort of, get a header, and do something with that, and post on path will do something else. And so you can see here that I'm describing. I have some information about the application encoded inside my functions. But then if I'm writing a client, this Vim is configured very differently than mine. Or my client for get path. So if I'm writing a client function that queries my API, and I'm going to give that off to some other part of my company, or some people external to my company that are using my web service, I'll end up writing similar things, right? So get path client will be make request method get path, and then some more details about how to serialize and deserialize those things. And then when I write documentation, I'm going to end up, writing Markdown. I might say get path. This does something really cool. And it's a fairly simple principle, right? Like when you start seeing these things, when you see the same things encoded over and over again, it's a very natural inclination to say, okay, how do we abstract over this, and how do we write it once so that we are sure that we get it right? There's no chance for it to be wrong. There's no chance that the client is actually making a request to the wrong endpoint that doesn't exist, or the documentation is out of date. And we have type less, right? We don't have to do this over and over again. It's a very simple, don't repeat yourself. It's a very simple software principle. And of course, the answer here is, look, we know what the basic, we know what it is that's being repeated over and over again in these different contexts. And it's a description of the API. So servant starts off from the question, how can we get a description of the API, reify it, and then start doing cool things with it? Interrupt me if you have questions, if something doesn't make sense, or if yeah. So the entire API of your web service, right? You describe it once. The idea is you describe it once, and then you don't have to keep redescribing it every time you're doing documentation, you're doing client libraries for different languages, writing a mock server. Each of these things is using the same information, and it has to be the same. If it's different, you got it wrong. So the entire description of the API should be the same, or at least in some cases it's different, right? So a reified description of your API will also help you make sure that you don't have broken links, right? So in that case, you're checking that a link exists within an API. That's a little bit different. You're only using part of it. But if you have an entire description of the API, if we have the get, the post, all of those things, and we do it once and we separate it out, we save ourselves a lot of trouble and a lot of mistakes. And so this is a very different starting point than thinking, I don't know, about MVC all the time, right? So this is the starting point, and the question is, how do we do this? To be fair, this is not an original idea. There are things like API Blueprint, Ramo, Swagger, that are basically API description languages. And they're pretty annoying. But in addition to, so there are two problems with them. One sort of more abstract, and I'll get to it eventually. But the main problem is that there's still space for mistakes. So are people familiar with these things? More or less. I'll describe it. So the idea is, use I don't know, a JSON array to describe, or use markup. Use basically this syntax, but be really strict about it so that you can parse it and do things with it. And so you describe your API once. You specify the details. Perfect. You specify the details. You then have documentation, and then you can create tooling that parses these things and generates client library functions. And so this exists, but the problem is that it's still a separate step from developing your web service. Those two things are completely unrelated, so you still have space for mistakes. You have to learn an entirely different syntax to understand it. These things are not extensible either. So you're sort of have to go into the lowest common denominator mode. Thanks a lot.
Characterizing servants DSL as exactly the same language program Haskell.
No, that's fair. That's fair. That's fair. It is the same language. It is officially the same language. But it's the same language. You're using once you start using servant, you're using the servant DSL to write your web server and the servant DSL to do everything else. Whereas with these other tools, you'd be using whatever language and whatever web framework it is, and then something else entirely that keeps changing to get the tooling, get the client libraries, get nice like HTML pages displaying what your API does. So this idea isn't novel, but it hasn't gone as far as the server itself. It's always been stuck on all the rest of the tooling, but not the server. And these languages aren't extensible. And what it means for how servant is extensible, I'll talk about later. But that's also a big problem. So we now decided that instead of writing the client or the objective, the client library is in, this has Haskell. If you're writing a very nice API, if you're a big company and you want to provide client libraries for everyone, if this is a very professional enterprise, you might try writing client libraries for a bunch of languages, right? Each one of these is a different effort. And then you write the server itself, the web application, the documentation. All of these are separate efforts. Instead, we're going to abstract away. The API description. And then from these, basically generate the clients, generate the documentation, and not quite generate, of course, but help out in the implementation of the server. So that's the basic idea. Does that make sense? And the API description is going to be a DSL. It's going to be a specific domain-specific language for describing APIs. So what does that look like? Sorry. So the first thing to notice is that this is happening at the type level. Did I move this so that I'm not in front of the screen? So this is a type synonym. It's happening at the type level, and this is a pretty famous or infamous characteristic of servant, and there are very good reasons for it. But for now, I'm just going to punt on that and say this is how it works, and then we can discuss a little bit why it works that way. So the description, the API description is going to be at the type level. How many people here don't know what data kinds is? Yeah. Okay. So I was wondering about that earlier. How many people here know what data kinds is? Okay. So the Haskell type system is very rich. The world of types in Haskell is very rich, and very, very nice to work with. And there are several extensions that make it even nicer and more flexible. And some of them, one of them in particular, data kinds, gives us access. Well, the relevant part here is that it promotes strings and lists to types as well. So this is going to be a string, but it's it's actually a type. So there's a type corresponding to integers, to strings. So when you see this, don't think of a string, think of a type. But it's nice to work with, right? This is great because it's familiar. Maybe not.
Individual string. Each individual
Right.
individual list.
Right.
That's not the type string. That's the type that corresponds to the unified string.
Right, precisely. So each individual string is a type. Not we always had the type string of which every string inhabits, but now we have the type a type called path. It's uninhabited. There's no value that has that type, but there's still a type. And so type operators. How many people here know what type operators are? So type operators basically the nice syntax that you have in the value level with operators. You also get it at the type level. So I could have called this, instead of an operator, I could have called it data sub AB, and then had sub path whatever. But instead, I could also use a type operator. No problem. So I could also have a type operator that often looks nicer. Right. So these two are roughly the same thing. One might just look better depending on what it is that you're doing. And then here, instead of sub path whatever, I would have this. So this is also a type. It's no different than the other types. It happens to take two. Yeah, to have and the idea here is that it'll look a lot like. The hope here is that it'll look a lot like your value level. Have the same sort of like nice characteristics of syntax than your value level. So to finish up, this is a very simple API description in the servant DSL. And what it says roughly is, I have one endpoint, responds to GET requests. The endpoint is in the URL path, and it responds with a JSON int. So the only content type that it can produce is JSON, and whatever it returns is an integer. Does that make sense? So this is a promoted. So just like we had the strings being promoted to separate types, we also have the list promotion. So this is a separate type than this, for instance. So if I can now get a bunch of types and put them together to form a type.
That's not a list of JSON. That is with a single element.
It's yes, yeah. So this is very different than in fact, this is again an uninhabited type. So it's not like so a list of int. We'll have will be like this, right? Right. Whereas this would never make sense, right? This doesn't make sense in Haskell. The tuple, if I tuple it, of course it would, but this doesn't make sense. So instead of thinking of it as instead of thinking, but this does, having two separate elements at the value level does have 1 and 2, and they're separate. And similarly, it's kind of like this. I'm going to have two separate elements. All of them are going to have the same kind. So they're all going to be just like at the value level, everything has to be homogeneous of the same type. At the type level, everything has to be of the same kind as well. So I'm just basically the type level list is just keeping a bunch of types. That
everything in a tuple. So we're making tuples out of these.
I wasn't.
What if I could maybe like give back JSON or plain text?
Then you would just add.
That look like?
Yeah. Then you would add plain text here. And so JSON is just a type. I can define it like this. And plain text is also a type. I don't care what inhabits it for now. Forget about types as something that your values inhabit, and just think of it as a separate language, a description language. Yeah.
Like the idea of a symbol as opposed to a string, or is there more you can do with it?
They are called symbols.
Yes.
Yes.
Yeah.
In the sense of scheme, which has magically n-term strings that are supposed to mean something other than string, but are basically just meaningless, but
different.
Things.
Yeah. Like
Yes,
at-
Is there more you can do with it than a symbol because it's a type?
Well, we actually call, so there's a kind we have called symbol, right? The inhabitants of that kind are strings at the type level, right?
Whereas this is something else.
No, this is.
No, I'm just saying the quote path is actually a symbol, right? So
Is a type of kind of symbol.
yes.
Oh, okay.
And then we have known symbol, which is a little class that lets you extract from the type, bring it down to the value level. Talk about it there. But otherwise, it's just a thing we can pass around through our code like any other argument.
So is there more you can do with it when you put with a symbol?
The analogy is only to the point that symbols and strings actually aren't different in any way, shape, or form in scheme, but they connote different things. Here they actually are different.
Let's
like concatenate
and you can't.
Types, you're not. That's not what you do.
And I don't think you can, right?
I bet, sir.
I have a trick.
Wait, really?
Sorry, I misspoke. I didn't mean sir.
You have to use reflection style. It's not fun.
Can you split them as well?
Yes, but there's going to wind up being a quantifier. You're going to have to do a little rank end thing.
All right.
I can show you how.
I'd be interested. But let's keep it simple and forget about it. Let's pretend that this is not mysterious and this is not the familiar types. Let's forget about the fact that it's types and just think about it as a description language. Let's just think of it as describing our APIs, and then we'll see how this whole type level stuff fits in. For now, let's just think of it as a simple description of the API. I think so. Yeah. So now we got started, right? We have now a very simple web service described. We know what it does. It returns JSON. It doesn't take any arguments. It doesn't take a request. There's no request that it expects. It returns JSON in plain text, or it returns an integer in either plain text or JSON. So what can we do with this? Well, so a common sort of pattern in development is that when you're developing web services and you have to interact with other people, either because you're writing the back end and and there's someone writing the front end, and they have to sort of get started on features together. One common thing is, again, the documentation, right? So the question is now, what can we do with this? What's cool about the fact that we've described it at the type level? API docs. So one thing we can do, and this will seem a little bit mysterious, but hopefully cool. One missing piece. We're going to need a proxy. We're going to need a value level representation of what type it is that we're working with. So that we can pass it around to things that. Right. So, what? My API. I don't know how to. Sorry, I don't know how to split the screen here. So I'm gonna have to do some terminal moving around. Actually, I can just background this, I guess, right? Right. So now we got an error. We already got an error, but this is a very good error. I swear. So it's asking us for a to sample. So we're trying to generate documentation for this, right? And we got an error because we're missing a to sample instance. We need to, in order to have decently good documentation, we decided that it would be great to have examples for each type. For each type that you might return, it'd be great to have examples. So we're returning an integer, but there's no example of that integer to put in the documentation. So let's do the reason why we need integer twice is because I screwed up really badly. We really only need it once. This is fixed in the next release. Sorry.
So you always have to make order for an instance like this in order to make up security guys?
Yes.
Please tell me that there's a new type or something.
Oh, there always ends up being a new type. I mean, this is really bad. This is really bad. This is really bad practice. Never mind Haskell. This is really bad practice from an API design perspective because we're returning a top-level integer as JSON, which we shouldn't be doing generally.
Yeah,
Almost.
It's not legal JSON.
Well.
The letter of
right. So yes, there is this issue that you have all of these orphan instances, but almost always you're wrapping. You have your own data type that you're defining yourself. And so now.
Sorry.
No worries. Why doesn't it exist? We generally decided that to provide fairly few instances because you should be aware of what is. Well, I guess the int is actually it should yeah. Right. So now, what? For int. Yes, although text is becoming more complicated, and yeah. Okay. So now let's write this to a file because it'll be nicer that way. Oh no. Sorry, this is not my computer. It's so here. So we barely did any work, right? How do I? So we barely did any work, right? We only just got started, and we already have something very nice, which is a fairly professional-looking description of our API, right? This, if the type level description of the API was scaring you, it'll probably scare people who don't know Haskell at all. But you can provide them this, right? And it's no extra work. It's right there. We're doing this trick, right? We know we have, in order to generate documentation, we already have all the information. You gave it to Servant by describing your API. So in theory, it should be possible to generate documentation, and it is. And this is it. It tells you the status codes. It tells you the supported content types because you put that list over there, and it gives you an example, a sample of the response, which is why we needed the two sample instances. You need to give a sort of example inhabitant so that we can generate this. And the great thing is that this won't get outdated, right? You can generate it whenever at startup time, and serve it in your server, and it'll always be up to date. You don't have to worry about the documentation being up to date because it has to be. And similarly, we can write a Ruby client. There's a pattern here. I really would prefer to have a split screen. Command T. Ah, nice. Not quite splits, but. Perfect. Okay, so the same strategy, right? So if you look at these two, they're very similar, right? So it's the same idea that you're passing to so this is a servant specific function. This is from Lackey, a library that Taylor Falsack wrote. But the idea is the same. You're passing the proxy that represents your API, right? So this is the proxy that represents your API. You're passing it through all these different functions, and they're doing something for you. It's the same, yeah. Then once you do this, you get a nice root. Well, not nice because we have to. RB. Yeah. That's the Ruby client. I don't know very much Ruby. I don't know if this is well written or not. But what? Yeah. And yeah, and so you see the power of this idea, right? It's I think hopefully slowly sort of becoming clear that you can do a lot with it. You can also do the even nicer is the way that Haskell clients are generated. So this is all cogen, right? So the Ruby client, for instance, is cogen. You're writing off the string, which is cool, but you know, like the function names might not be what you want them to be, and they might not match up when you change your API. And and you're leaving the system basically. It's not internal to the. You can't sort of. It's not a first code generation. Is not first class, but the Haskell client is first class. I'll do the type after in a second. So here I had to provide an extra parameter, which is the base URL. But the pattern again is the same. I'm passing to this servant functionality the proxy, and the extra component is just so that we know where to point this to. So what would the type of this what would the type of this be? Right. So ideally, it should return an int in some form, because our API endpoint returns an integer. So it'd be great if it returned an integer and we didn't have to worry about anything else. On the other hand, lots of things can go wrong, right? Like there could be a connection error. For some reason, they could throw a 500. So we have to wrap this in, and it has to do I/O as well, right? Because it's this Haskell client is going to query a server running in localhost 8000. So it definitely has to do I/O. So we put in the teeth to sort of have the option of with a servant error, to have the option of failing, and then there's I/O, so that we can actually do I/O. Right, and now we have a Haskell client. We have a function in Haskell that queries our API and selects the right path. We didn't mention it anywhere here. There's no mention of the fact that it's being served in path. But it does the right thing because it has all the information about the API that it needs. And of course, it does the right thing, but our server doesn't yet, right? Because it doesn't exist. So we get a connection error, not unexpectedly. Okay, so we're circling around this. Eventually, we have to talk about the server, right? Eventually, we have to talk about how Servant actually is a web framework. So far, I haven't been talking about the fact that it's a web framework at all. I've just been saying, oh, look at all these cool tools that you get for free. I'm going to do that one more time, though. And that so in the development process, you might be interacting with a front-end programmer who needs to talk to your service, or else some other web service that needs to talk to your service. And maybe you're developing in parallel, and there's always this problem where you're the person that everyone depends on, so everyone has to wait on you, or else start in parallel and then have like miscommunication and fix things at the very end. And so it's a very staggered approach. Here you can actually, in addition to just giving everyone else in the company documentation about what it is that you're going to do, you can also, from day one, from hour one, provide them with a mock server that will respond in type-correct ways, in exactly the same way, in a way that fits your API description. So it will respond with an integer in path, and it will respond with a 404 everywhere else. It'll be an arbitrary integer. Actually, let's just do this as Let's see if that worked. Right. So again, the last thing I'll talk about before actually talking about server is mock. And mock again follows the same pattern. You pass it the proxy. It again looks at the proxy and tries to figure out what to do. And in this case, what it's trying to figure out is how do I write a web server that fits exactly in the description that you gave me. So it is an instantiation of the API that you said that you were going to write. But do the bare minimum necessary for that to work, because it's an entirely automated thing, right? And this is, yeah. So then we can, well, D? Yeah, nice. No. Okay, so the server is now running. It responded with a not found, but that's expected. What is going on? Sorry, what? Oh, okay. But this is a terminal thing, not a. What? But even then, it won't. Yeah, it's still doing.
Unintentionally. That's the intentional curl behavior.
Okay.
He doesn't want you to think this live.
Well, whatever.
Command. Put it at the end.
So there's a random number that I'm getting. It's sort of being so this 11 to before the LT stuff. I'm getting a random number back, and this is the response that I get to the right path. If I try anything else, I'll get a not found, which again is being eaten up. And so I already have a server that does what I said my server would do, and I haven't done almost any work. And we can see here. So the runny this key that we had before now works, right? Because we have a server running, and it's almost hard to believe. It's sort of almost hard to believe that this actually is talking to a server, because it feels very much like it feels very much like RPC. It feels like you're just calling a procedure remotely, because it's being deserialized. It feels exactly like it was a local thing, but it's not RPC, right? It's much better because it still has that sort of introspectability that REST APIs do. But when you're programming in Haskell, you get a client that's very well behaved. It knows that it needs an integer, so it already deserializes your response into an integer. And yeah. Any questions about this? The example. Why we wouldn't use that? Yeah. So I think the reason why we don't want to do that is partly because it seemed like a really good idea to provide a mock server that's a good mock server, right? So if someone is writing a Python service that is interacting with yours, they can, in order to run their tests, there's always a question of if you have a dependency on an external web service, there's always this question of how do you test it. And unrelatedly, we have an answer to a different question that pertains to testing in Haskell, which is quick check. which is the answer to all the testing questions, right? So in that sense, it seems like a really great idea to provide that to other people, right? They can test, they can use QuickCheck, they can use Haskell's QuickCheck as a mock server for their testing. But we could have used 42. Does that answer your question?
When you're making your new type, you can make your arbitrary instance do what you want. You're using a new type, right?
Dude, should I wrap? Are you going to be upset if I don't wrap this right now?
I'll stop shaking.
You would need to write docs for a whole bunch of things that you might already have or vice versa.
Yeah.
Like
Yeah.
if you're going to do quick check instances, you'll have them anyway. Right? Otherwise, you would have to write like 50 or 42.
And so the problem with that is that arbitrary is very poorly behaved as for documentation, right? So just imagine if the documentation. In addition to that, well, you can maybe set the seed somehow. But in addition to that, I mean, you have to make sure that you don't get like the crazy control characters that QuickCheck will naturally and very reasonably use for testing, right? If that's great for testing, but it's terrible for documentation.
Or really long list.
A really long list, yeah. I mean, they're trying to basically the QuickCheck is picking the craziest examples, and you want the simplest ones, right? So we could have, but it seemed more reasonable to actually give you to make you sort of pick better examples, right? Yeah, they can. In fact, the way in which one way of working with something that I think is interesting is to have your API description and your data types that belong to the API that are actually either expected or returned by your service as a separate package. And then anyone who's using Haskell as well can just do docs that API, and one line of code, and they'll have a server, a mock server, or another line of code, and they'll have a bunch of client functions. So the API can get more complicated, of course. And I'll explain a little bit what the syntax of is that everyone okay so far? I'll explain a little bit about the syntax. So this is basically sort of saying more about the same path, right? So with this symbol, I'm saying, oh, it has this property, namely that it responds to the URL is path, and it also has this property, which is that it's a GET request which responds to JSON. And so we have different methods. We have get, post, put, patch, or delete. And they all look the same. They all take two arguments, one of which is the list of content types, and the other which is the return type. We have this symbol over here, fish, I guess, which combines two separate sub-APIs. So now I have, so now I have two paths. Right, so this is, in case this is unclear, I'll sort of write this out in right. So now we have two paths. And the interesting thing is that if I only comment this, not unexpectedly, all the documentation and everything else will I don't know what's happening. Yeah, so let me write this file again. Right. So now we have post and get described. And again, so usually you will set this in your main loop somewhere to generate these things, or have it be served in an endpoint. And I mean, it's the same idea, but it happens automatically, right? And this will happen with everything. It will happen with your Ruby client. It will happen with your JavaScript clients. Things get a little bit more interesting when I uncomment this. So what should happen? So I just changed my API. It now has 2 endpoints instead of 1. What would we like to happen? Yeah. We would like a type error, right? Because this is a type that we want for a single endpoint, but now we're asking for for functions that query all the endpoints, and now there are 2. So hopefully this will be a type error. Right. And the type error says exactly what we want it to, right? So could not match this thing, namely, so this fish exists. Yeah. So this fish shows that they're in fact 2 different paths, 2 different client functions, and we were expecting 1. So I can pattern match to get both of them. Sorry. So here, so if the result of this is going to be 2 different functions, then I can pattern match and get both of them separately, right? And now I have the two client functions. So this is a value, and the fish at the top is a type. Was a type, right? So the
It's not at the same kind as the one at the top.
I don't know exactly what you mean.
Can
It's
you go back to the window that had the error message?
yeah. This is somewhat difficult for me, but yes. Yeah. So here.
There, that has things with time star on either side.
Right.
But at the top of your program, it's got things that are API. So I'm confused about what the kind of fish is.
So API is not a kind, but sorry.
I was just going to say
It's just it's just polykinded. So yeah. So yeah. So you're right. Fish is polykinded on the left hand side, but not on the right hand side. Right. Right. So now I can run either T, get, and post. And this is interesting, right? This is nice. So get worked, post didn't work because we didn't restart our web server. If we recompile and restart it, would work. So yeah. Okay, so no. Yeah, so um, so I don't know. I think this is cool, and can we what? Oh, if you write Hadox here, it won't.
If you run Haddock on this,
Yeah,
it won't generate documentation.
that's interesting.
Yeah, it doesn't actually seem to understand
Pattern matching. Yeah.
Someone may have hit this and figured out the magic thing that has Haddock to do. I've been too lazy to remember.
That's interesting. I've never looked at the Hadox that I did. But actually, not a problem with it. Well, yeah. Okay. I didn't know that. Thanks for pointing it out. Yeah. So we can keep making the API more complex. We can add a request body. This is another combinator, and the idea is very much the same as the methods. It also, let's new type wrap this int.
I'll take it. Oh, edifying.
Let's try.
Uned stops it from being meant something much more.
Is it? I think it's not. I'll also to do this, I would have to. Yeah. Okay. So let's edit the Cabal file to get. Really not worth it. So now I have to depend on quick check so that I can get. Okay, let's see if. Yeah, but I also didn't actually get ASIN. So what? $35. Yeah. Okay. So. GHC generics. And this is. And let me, for now, comment this out. What? Yeah. No. Can I now delete this line? Is that the yeah. The what? What was that? Oh yeah. Oh yeah. Well, I don't need that, right? Because I can now change it to I didn't. Okay. I think now we're done.
Generalized new type driving.
Derive any? Wait, derive any would do that already, right?
No, you need generalized new type driving.
Okay.
It's not using generics.
We have just shut up and derive it already.
Just shut up and derive.
Richard wants to make that more complicated at last check. Like, which one of those did you want to have generated rather than some ad hoc rule like we have today? Want to take the non-instance inline then?
No.
Oh yeah.
Yeah.
Oh, it's your drive any class.
Because it's confused. Yeah. I'll just do the to sample as in add int. What? So much better than our fins, right? Just have.
You're the one who threw classes into the mix.
Okay. There are. I can remove the generalized new type deriving, I guess.
There's a reason why Richard wants to make that story more complicated, because stuff like this happens when you start using that.
Yeah. This can be ignored. Well, it's this is the confusing thing about minimal, right? When you have generics, you have a mention of the minimal implementation for a class, you're going to get these warnings, which seems like a bug. Yeah. So now we switch to add-ins, but otherwise nothing's changed. Let's go back to the request body though. So the request body, as we might expect, it says now we need a net int provided. So the client function now needs to provide a net int in order to get a net int back. So if we try reloading now, again we'll get a type error, hopefully, because the type that we gave for post is wrong. Post now requires an argument. And so there's this is getting at the essence of why it is that 7's at the type level. We want all these errors. We want all these types figured out. And if we had it at the value level, if we had the description at the value level, we would be on the wrong side of the phase distinction. We don't have 4 different types. We can't have the types of our client depend on values. Yeah, or like actual code gen, right? Like yeah. Yeah. Well, I mean, even it's. Yeah.
Oh, you said this is the reason why I keep wanting to specify your pronouns. What is the this?
So the reason is we're getting type errors as we are changing our API. We're adding now a request body, and so we would like the client functions to change, the type of the client functions to change, and that desire is the reason why having the API description at the type level is important, because the types can't.
Use Haskell's type reference sensibility to make errors about type. To say, oh, you just changed your API.
Right. Yeah. So this is the type safety that we want. Yeah. Yeah. Exactly. So if we implement the server and we change the API, then the server then it won't type check, right? If we added a request body somewhere, it won't type check.
So you have to be really comfortable with Haskell's error knowledge. You are.
It'll tell you what it is that you did wrong, why it is that what you wrote isn't the implementation of the server that that you said that you were going to implement, right? Which is, yeah, so we want that safety. We want that.
Tell you very quickly.
And sometimes, yeah.
Tell you
Yeah.
something. Roughly where you should.
Yeah. Right. Hopefully that one.
I'm trying to make these things indistinguishable, but I can still
So let's try implementing the server now, right? So let's quit using the mock server and actually try writing the server. So we're going to need. I'm going to change the name of this to getC because this is the client, and this to C. So our API has two endpoints because that's what we said that it had. So let's write two handlers, get and post. The type of what should the type of the get path be? Yeah. So basically, you can also it's also it ends up being either T servant error IO int because generally with you want I don't know like using IOs in the web service is pretty common. You want to check the database and whatnot. And also you can use a left to indicate non 200 2xx response code. But basically an int. Yeah. You still use a left, which is dark. Yeah. Which is dark. The trade-off there, the trade-off that we've talked a lot about there is that if you want to have multiple possible success response codes, your types get even bigger. And we started looking at all the other instances in which this might happen.
making the correct decision depends on the method. First place.
Yes.
If it's a delete and you don't have a body, then it should be what, a 201?
Yeah.
Yeah, no, it's terrible.
Well, the way in which the way in which we do it for no content is we just assume that unit is no content, but of course that's very static, and sometimes you have no content. So it gets yeah. So it was basically a trade-off between having this consistency of allowing you to have multiple success static code for the same handler versus simplicity. Yes. If you want to put it that way, yes. Yeah. No, so servant error and servant error are two different things, slightly different things. One is the yeah, it's a little bit unfortunate, right? Because there's a so when you're dealing with a client, there you can have connect errors, right? So the possible errors that you get back from a client library function are larger than the possible errors that you can throw from a handler. So we have different types of those. It either contains a servant error or a connection error. Yeah. Yeah. So the type, but otherwise the type is very similar, right? So this is what I meant by saying that it's almost RPC. It's almost like when you call this function in a different library somewhere, it's almost like you're calling this function. The types are almost the same. You don't have to do any marshalling or unmarshalling. The only difference is the connection error. And so you get to use Haskell and interact with your API if you're using Haskell on both ends, as if it were RPC, as if this weren't a remote, if this were all a library function. So the post is just going to return the same. Oh, this has to be edit.
This is by far my favorite.
Post?
Ada. The only one that doesn't make me like this really angry. And it's still terrible.
We might not need a name for that function.
Go up.
So now so what I'm doing now is writing the actual handlers, right? So I need two of them. Because I have two endpoints. I described them as having two endpoints. The types are already determined for me. Just ask JC what they are. And then I put them together in the same way that I was destructing, pattern matching to get the client functions. Now I'm putting them together to get back the server that is the entirety of the API server, right? So no. I don't need any of them so far. Yeah. For proxy, yeah.
For my API.
Yeah. I don't need this one. I don't need the get and post ones. Yeah. But of course, I mean, even for your own sake, it's well, that's always the case, I guess. So serve is the so you might have been noticing that basically servants split up into all these different packages that handle basically interpretations of the API description language. They're all evaluators of this description language. And the way in which it usually works is that there's this evaluation function, basically, docs, client, Ruby for API, and serve that takes a proxy. Serve is the server version. Right? It takes a proxy and the implementation of the server and runs the server. Okay, so now I have an actual server that I actually implemented running, right? Let's try. So 8,000 will curl. the unsupported. Please look the other way about the unsupported media type. This is one of the most exciting things about 7.05 is that we finally fixed this. So you may have noticed that I requested the wrong path, and I got unsupported media type back, which is terrible. This is finally fixed in the upcoming release. If you don't say what?
So if I say that something only gives back JSON, do I need to have the accept header?
Yes. No, you don't. You don't have to have the. It also assumes that if you don't have so both content type and accept are guessed. So for instance, in this case, it's giving me back 42, even though I didn't specify the accept header. So the way in which it works is that if there's a list of content types and there's no content type or accept header in the request, then it'll just pick the first one. So now we have a server running, right? And again, of course, like if I this should be obvious by now, but if I delete the request body, the server won't compile anymore. Right, so again, I don't know, the server the error messages aren't always that bad. So there's also, in addition to this sort of type getting type errors when you don't implement the correct with respect to your API description server, there's also a lot of other things that are happening here that I think are interesting. So for one is that your handlers basically don't know that they're dealing with sorry. This is an associated type synonym. So it's not injective, so you can't work. So it'll get there. Yeah. So I could also write, for instance, either T servant error. So this will become so server. Can I answer that question in a little bit? The problem here is that I have to sort of explain how this works, what server actually is. I haven't said anything about what this is, right? What server means, and but the basic answer is it's an associated type synonym, and those are not injective. That might not be. I don't know if that's satisfying as an answer, but for now, it'll be the answer. Yeah. Yeah.
You're defining those two functions, rather these two values, get C and post C. Then you've got the fish operator between them.
Yeah.
Are you defining a new operator with that? That's taking the arguments, get C and post C, or what exactly is that?
So this is pattern match.
Okay.
It's top level. Yeah, top level pattern match.
Find a pair.
Yeah, so we could so this could be seen as get C, comma, post C, right? In fact, the fish operator is very much like a tuple. Yeah. In fact, exactly like it. Yeah. Anyone else? So it sometimes matters, and the way in which it matters, I think, obviously the answer it sometimes matters is the least satisfying one, but I think actually the way in which it matters is the correct one. So let's say that I have two endpoints, right? Post dot string and post dot int. So let's say that I have two endpoints, and they both have a request body. They both expect a user. Say. Let's say that I have this, and they're combined with this, right? So if I instead do this, wait, but
I meant like when you have, you needed a header and a request body, you swap the order of that header and request body.
yeah, it does. It does. It matters. So the path. So in this case, so the path doesn't matter. But if I had a header and a request body, then it would matter to the implementation of the server, because the handler would get whatever the header is first in one case as the first argument, and then the request body. And then if you flip them around, then you get the request body first and then the header.
If you want to derive a function that needs to be given a header, it needs to be given a request body, then if you compose those, the derive function will want them.
And in this case, it's a somewhat more extreme example. Instead of having on the top here, I would have two handlers, both of them functions from user to string or user to int. And in the top, and in this case, instead, I would have two functions combined with fish. And in the second case, I would have one function that returns something combined with fish. It's int and string combined with fish, right? So the shape of your types and your handlers and your client functions changes depending changes depending on changes that aren't that form a sort of natural equivalence class on APIs, because they're actually the same API, but in a very natural way. It is sort of the most reasonable thing, I think, that you could do in that case. Yeah. What would you? Yeah. So the nice thing. So the nice thing about it's sort of very what turned out to be really nice is that you can always so let's say that I was working on this API. I can combine it, and I have another one, which is just get unit. The types are first class enough that you can they can do lots of things with it, right? You can split them up into smaller components. Right. So if you have 100 endpoints, you can say, okay, like there's 10 endpoints in the user endpoint that are under user. So let's pretend that this was user API. There are 10 endpoints that are in user API. There's only one in this case, but I write all of those in one module somewhere. I write 10 more endpoints in another module somewhere, and then sort of maybe even following a directory structure, I sort of start building them back up until I get to main, and then connect all of those sub APIs together. So you do have to use fish between everything, but it doesn't have to be in one huge API description.
So the routing of paths to handlers is done through definitions of the paths down the tree.
Yes. Yes. How would you?
So I might imagine other web frameworks let you annotate the handler, the string representing.
Yeah. So no, it is positional. It is positional in the sense that you have to match the handlers to the position in the API. So yeah. So
You
the
can only screw up if you have a lot of different templates of the same types.
yeah. Yes, that's exactly correct. There are some
Proliferating eds, you know, is
because you sort of have to new type wrap a lot of things anyhow. It may end up okay. But the other thing is that actually a lot of so we saw the client where you're basically pattern matching, doing the same thing, right? So everything's positional when you pattern match on the client. The function that you get out depends on where you pattern match and right. So the reason that get C is get C and post C is post C is because of their order here. Similarly with server. But there are some interpretations in servant. So for instance, there's a type safe links where basically you give an API type by a proxy, and then it tries to match against. So it's not really, yeah. So there is the other mechanism already exists in servant, but it hasn't. It's not clear how we would use it to work with the server interpretation. If that makes sense. You don't always have to be positional. You can search down the tree with a description of the types that you expect. And in theory, that could possibly, for the client, it could work. So type safe links. So there's a safe link function which takes my. Let me fix things so that this compiles. Where? Yeah. But so with HList itself, then we don't care about the value level, right? So we could have a type level list. Yeah. Yeah.
Vinyl, you could use like rec proxy.
I don't know. I've never used Vinyl.
So Vinyl says, you say, I have a record. For each one of the types in my list, I have some F. I'll give you F of that type. If you use proxy, then you have a linked list, basically, of proxy records, which is absolutely boring, right? It's just the length of the things. The value level inhabitant of that is almost trivial.
Yeah.
So if you want to pass around such witnesses, which are just the type list, and
a bunch of proxies,
including the length, it's just a bunch of proxies.
Yeah.
So Anthony Cowley came out and gave a talk last year, was it, or earlier this year? I don't remember. On his frames package, which he used for chamber. So there's a recording from earlier this year.
Cool.
You might want to take a look at that.
But syntax, yeah. So someone had a question about type safe things. Sorry, we could do this. We could use lists for at the type level. And that would be totally legit. Yes. So this safe links, basically the idea behind a safe link is, link one. So this is going to be a link to get.
Regarding the vinyl record, one of the things that they talk about in there, the notion of a variant. So it's an index safely into a type level list. They talk about the type level slot.
Yeah.
Or a slot that has
Yeah. Which you can also, yeah.
You can also build it on a one-off basis.
Yeah. so there's a safe link function that takes. So how would you? So intuitively, one way in which you might do type safe links is you have an API type, an API proxy that tells you the entire API, and then you give it another proxy describing the link that you want, and it will only type check if it'll give you a string or a link data type, and it'll only type check if your if the second argument, the one that you want to be a link, actually exists in your API. Does that make sense? So I think I have other type errors. So let me fix those first. Oh, nice. So let's do something that we know that doesn't exist in the API, right? So there's no delete endpoint. Might have gotten the arguments wrong. How do I close the tab on? Close, yeah. Right, so we get a pretty terrible error message. Because the type family is trying to figure out all this logic. But you can kind of make sense of it, right? So could not deduce or is a lem. So is a lem basically says delete is an element of that. So we have two endpoints. So our API type will belong to our link will belong to our API if it's one endpoint or if it's the other. And that's more or less what you get here, right? So we could not deduce that delete is that, or else delete is this. We get a type error if we try to generate a link that doesn't exist. On the other hand, if we do right, so now this type checks, right? Before complaining that there's
So in the previous error,
yeah.
right, in fact, if you just delete a path,
Yeah. If I did.
So it's complaining that it doesn't have the method anywhere.
It's complaining that.
But it's not complaining that there's nothing in slash, which is what I would think of as the first thing you look for is slash. And oh no, it's saying exactly that because there's no.
Yeah.
Oh, that's confusing. So if you gave it a path that wasn't there, it would complain about the absence of the path before it would complain about the right, because delete is actually slash colon greater.
Because delete is actually slash.
For me in the version way.
Of course.
And I will see at least what I'm looking for.
Yeah.
Anyone else understand what I'm asking about? I know what you're saying. See path there?
Yeah.
Proxy
yeah.
Path?
Yeah.
Change path to
I don't know if I can, but I'll
he spelled it in QWERTY. I usually spell it.
So this is the type of error that we get.
Okay, yeah, that's much more.
Yeah.
Okay. No, it really looked like it was looking for the method first, and then if it couldn't find.
Oh no! It just so happened. No. It just so happened that the example that I gave it was just the method.
Yeah. Sorry.
Yeah. No. Sorry. It could be nicer, right? It could maybe try to like do some matching. What?
Depends on your prologue.
Depends.
You have somewhere in there a little logic program that's saying, right, this, and it looked like it was picking it apart from the end.
No. It will. It will actually do something. Yeah. So I don't know if I should explain. I think you understood exactly how it works. But
the root of your web service is implicit, and it's hard to see that in the error message.
Yes, the root is implicit, or rather, there are multiple ones. Sorry. Yeah.
What do you think the error messages, like, presumably the error message you tend to get with this are a subset of all of Haskell's possible error messages.
I would say that they sometimes feel like a superset.
Error message is a big open problem right now.
Yeah. So really
making them better.
Is something specific about, or a thing that tends to come up a lot. The sort of patterns of error messages, which is why really understanding very quickly.
So this pattern does eventually become familiar, but the error messages could be better insofar as we could basically when we're going down the tree of the API, and we're saying, okay, either try to recursively match against this and this and this, and then so basically, if you have if the link that we're trying to match is path delete something, and the API is path get something, some path post something, it'll try to match against both, and it'll manage to match the path, and then it'll try to match the next part. And so eventually, one of the other problems, in addition to the ugliness of the error messages, even in the good cases, is that eventually you only get, you don't have all, it'd be nicer if you could reconstruct the entire search tree and say exactly what failed to match at different points. So you could have an accumulator as you're going along and sort of like keep saying like what it is that you tried matching and where it is that you failed. There are sort of getting error messages to be good is really hard.
Leonard got a nice presentation on this as like a lightning talk at ICFP this year.
Doesn't but he also has his own compiler.
Yes. He's basically lobbying Simon, like, you should implement this thing. And Simon's like, okay, give me a specification. I saw he's doing something very similar, and I think the sort of error issues with error messages, type error messages, are similar in both cases, but he has his own compiler.
The problem here is that you have a sufficiently domain-specific language that you want domain-specific error.
Yes, exactly.
And this is leaking the way that you implemented relatively same logic. You want to say, I don't have a path like that.
Yeah.
And instead you're saying, here's the heap when the prover failed.
Right.
Leonard's last proposal there was not just his usual two error thing, but it was like make a constraint that could never be satisfied in any attempt to satisfy it. It's like got a symbol as one of its arguments.
Right, because
to use it,
prints
out the symbol argument with some big.
Which is terrible because in a sense that's the most annoying thing about type with that. When you have type families that are constraints and you want to say, okay, like this is really never going to happen. You can't do something like true equals false because then you lose all sorts of information about the type pairs. And really, you know so much about what exactly the branch is that's being tried, but you can't give that very nicely. You can create data types.
If you wrote this whole thing as a template.
I'm getting the sense that.
There you go, actually. It was half a joke.
Practical question about cycling. You have to generate the entire path from the root of your tree down to one of your gifts.
Yeah.
If you were factoring specification of your API, you're not going to have total paths available. Like if I have a little subtree defining like CRUD operations on some source, I need to assemble that all the way into the full tree, and I can't get access to it. Is there you guys run into that issue? Or?
But eventually you assemble the entire tree. Right?
Eventually you assemble the entire tree, but that would be no longer. I can't point out that I was really anticipating this leaf of it.
Yeah. Okay. So if you're working in a subtree and you would like your link to work in the master tree without being aware of the master tree, then you have a problem.
Have you had a parameterized function, a parameterized type? Like I've done the thing you're talking about with CRUD, and all of them take a little. They're all type aliases that take an argument that smash stuff onto the beginning or shove it into the end, right? Because you don't know, right? Your safe link is actually parameterized on the root, everything that comes before it. So you already were writing a function. Yeah. And it might even work. I haven't tried to say.
Yeah, no, I think what you're saying actually would, in a sense, work. You could write a function that it would be more work, and we haven't done this, but you could write a function that says, okay, we'll give us, instead of giving us a full proxy, eventually just give us the path up from the subtree, right? So if you're concerned about the CRUD, and then tell us what the rest of the thing is. So you could make links that just require as an extra argument whatever else is missing. But you have to, huh?
I can show you
for clients.
It's still wretched.
Yeah. So I guess this should be mentioned maybe, right? The CRUD. So you can do a lot of things with just type synonyms, right? So if you see yourself writing CRUD endpoints a lot, they will. So if you have, let's start with the base case. So let's start with user. So user, sure. So captures so often known as semicolons is when you have a part of a path, and you want to deserialize this into you usually often have something like users and then ID, right? So if this is a number, then this will work, and if it's not, so if this is a path. So users 5, users 10, or users 15 would work. Users John would be a 404. This is how other web frameworks often express it. Here, and we express it with this capture type. Right, and throwing a 404 if it can't be decoded as whatever type it is that you said that you wanted.
What role does that simple ID play there? Is that just for the documentation?
It is just for documentation. I feel qualms about that. What?
Do you use it for the variable name of the generated command library?
We do use it for that too. It doesn't have any sort of functionality in the server itself, though. Capture ID. So you might often end up writing things like this because they're the classic CRUD. Lucky? Yeah. Well, I need to write extra data types now because I have all these. So delete, what else? And maybe a listing. I don't know. But this is something that might show up very frequently in your API with slight variations, right? So maybe users changes this URL here, and maybe the type here changes, this one, and maybe the type over here. So you can abstract away this stuff, right? So first, we could delete this these initial paths and then just put them outside. But we could also just make this basically right. So now I'm abstracting. So now the servant DSL itself is becoming more of a real language, right? Now, in a sense, this is the servant DSL's functions, basically, right? So CRUD ID user is a set of 3 endpoints. A set of 3 endpoints, 3 CRUD endpoints. And if I just change the ID to name and cat, again, it's another set of 3 CRUD endpoints. So you really can you can really sort of like begin abstracting a lot and treat the servant language, even though we haven't. This is not us. This is just Haskell. You can really start treating it like a language, right? We saw this sort of when the question came up of like how do you split up 100 endpoints. You do the same thing you do in any language. You assign variables and write functions, basically. Yeah. I kind of wanted to get into how it actually works.
One question. Is there any protection against as being defined?
No, but that's easy to do. To have the same path twice.
Well, you were saying you could like pull off some of the stuff.
Yeah. Yeah.
Someone accidentally.
Yeah. So it doesn't complain now. It's easy enough to do in the simple cases. It's not easy to do. You don't statically know whether a capture. So if you have 2 endpoints that are both path users and then get something, and path users get something, then you're fine. You can check that statically whether they match. If there are overlaps over capture, then you can't do that statically, right? Because you don't know whether you don't know statically whether it is an overlap. If this capture is, for instance, an int capture, and you have users 5, then you have to figure out whether 5 in fact deserializes into the string 5 deserializes into an int, which you can do at runtime, but you can't do at file time.
Regular languages to look for overlap. Or you do it.
I'm getting the sense that
it's just the callback to the previous.
We wrap the int type, but the toJSON instance will be the same. Yeah, okay. Sorry, that was wrong. An edge, right? Because the generic rather than new type. Yeah. Yeah. Well, is it inferring? I was inferring the wrong thing. I feel like I made a mistake.
GND should give you the right thing.
GND.
Generic type driving should just give you the variant.
So yeah, so the generic version gives you the dictionary, and the GenD gives you the int, right? Yeah.
Sorry, I misread something. Oh, right.
Yeah. So I'm not using GenD. I'm using derive any. Which I mean, this is we kill two birds with one stone, right? we can't do top level ints. I guess it's.
So can I ask you about that actually?
Yeah.
For the examples, did you consider having another type function like you have server my API? Did you consider having the example my API and then forcing people to provide the examples explicitly? Because it seems like pulling examples out of types is a dangerous game, right? Because like let's say my thing is a calculator, it takes two integers and it shows the third one.
Yeah.
If you just use your sample instance for integer 3 times, you're going to get say the same number 3 times, and it's going to say 42 plus 42 is 42.
So if I'm getting it right, you might have an endpoint that multiplies a number by 2, and then you have a 2 samples that is 42 for the request body, and you have an example that's 42 for the response body, right?
Right. And so I'm not sure 2 sample really makes sense. I think you'd almost be better off having to explicitly provide term level examples, because then you could do more than one. You could pick values that are explanatory to the users.
So the way in which 2 sample works is that you can implement there's 2 sample and 2 samples. This goes a little bit in the direction of what you're saying, but maybe not sufficiently so. And 2 samples, 2 sample has type just a, or edint in this case. Maybe edint. And 2 samples has type text, a tuple of text and edint. So you can then provide a description of in which cases. So if you, for instance, have multiple constructors, you might say in cases this, then you get this. But of course, it doesn't. Your samples will not be allowed to vary depending on the request. So you still will have the calculator problem. Right? But you'll still to some extent have the calculator problem. You could say, okay, when, yeah. How's everyone feeling? I feel like if I start going to how this works, it'll get quite late.
We tend to run long.
Yes. Okay, so then. It's what? Yeah. Well. Okay. So then let's do the very simple description, and then just hand wave everything else. If you want to write a type level in DSL, this is how you do it. We're very familiar with so let's write a simple expression language. Add a b mult. Yeah, so let's do literal. I guess that's a more literal int, right? Sorry. And then you write your evaluation function. It takes an expression and returns an int, and it does, I don't know, add a plus b val lit a they. Right, so this is, I don't know, a classic way of doing it. There are many others. What? Oh, more vowels, yeah. I don't need this. The problem with this is that you could like also write preprint, which would take an expression and return a string. But the problem is that it's not really extensible, and then the other problem that we mentioned is that sometimes you want stuff in the rest of your program the types of stuff in the rest of your program depend on the value on the particular expression that you're working with. So I mean, yeah. So you can do this in the value level, but by just using classes. And then essentially where the constructors become, so the functions become classes. The constructors of your expression become data types. And each pattern of your evaluation function becomes an instance. Possibly recursive instance. So does this make sense? What's going on here? Let me explain it once again. So let's say that we want to write a function that evaluates a sample expert add 5 3. But this is a type level, right? So we had the example before with the data type of how to do it at the value level. And the basic, the somewhat fairly simple idea of servant is that we can do this at the type level as well. We can write an eval prime function that takes a proxy and returns an int, and then evaluate stuff of evaluate sample expression, which looks a lot like this is important. This is kind of a saying. It looks a lot like the value level equivalent, but it's really at the type level. The promoted val. I don't see where eval. Yeah. Oh, do you mean just change the kind here? Yeah. That wouldn't so. Yes, but then we would lose part of what we came here for, right? Which is extensibility. Yeah, yeah. So the nice thing here is that whenever I want, I can just add a new exponent, say, and then and I don't have to touch anything to recompile it. So this is I mean this is the essence of the idea, and with again, I'm going to try to do this very, very quickly, so I'm going to be quite. So we're going to use, for the server interpretation, we're going to use something like this eval function to evaluate type level expressions. But additionally, we have an associated types in them, which is nice because we get to. Here, let me see if I can. Is there? You see typelets, known symbols. Oh, scope type variables. All right, compiles. Doesn't yet work, but whatever.
Somewhere is that in PHP as part of the full machinery to like.
Wait, what is?
Proxy, is that something that defined in your library?
It's in base. Courtesy of you.
7.8-ish something brought it into base from my tag.
Yeah, so it's in base.
The definition is. Yeah, the definition is just data proxy A equals proxy. So we could get fancier than what we're getting. So here we're not yet using the big advantage of doing this in the type level, because even though we're evaluating stuff, we get extensibility, right? So we can add new terms to the DSL. But the other big advantage is that this having the response, the return value change its type, for instance, right? We can't do the value level, but we could at the type level. And we're not doing that yet in eval, but we do that in has server. So in this interpretation, we change, depending on the value of the expression, we change what the argument that we expect is. So, for instance, if we're going to write a let's think of a very simple version of servant that doesn't have all the machinery for content types and whatnot.
Just give a post today about writing a simple version of servant.
Andres did. So here we equals A. So here we're writing a very simple version of servant where there's no I/O, there's no either T, there's no content types, and here what we're saying is, look, and in order to do that, in order to describe a combinator, what we do is we describe basically what the value of the handler that combinator expects or is equivalent to, basically. So get, if we walk down the tree and finally got to get, and it says it's a get int, then for simplicity we'll say, okay, the handler has to return a name. And then root says, okay, like given that you have what you asked for, so in this case A, right? So how do you make an application of that? Application is request. Well, basically, let's pretend that it's request response or IO response. So then we get another request, and then you can do whatever you want, right? So, so here we would just encode response. Are people familiar with Y? So we're basically working with Y, which is currently the underlying application interface. Although I have something to say about that in a moment. And then encode array. So basically, there's some function that's provided that that sends the response. So we just encode it with the toJSON instance because we know that there's a toJSON instance, and we just respond with that. So that's the essence of it, really. Once you get that, you can write your own combinators and whatnot. Yeah. So the thing that Ed mentioned. The blog post that Ed mentioned, I'll put it up on Meetup. Andres's blog post sort of gets this done, and he's much better at explaining things than I am. So his examples are also much nicer. So you should probably do that. Yeah, use that as the go-to reference rather than me. Yeah, but this is the essence of it. You can once you know that, you can write your own combinator, right? So you can write like some combinator that does, I don't know, like it checks that it hides an entire API if it's Monday. It's a sub API, right? So you have a private API that works every day of the week except Monday. Is not Monday. If not Monday. And this sort of stuff is becomes pretty easy to do once you get a sense for it. Here the type of the handler will be exactly the same as if the combinator were not there. If is not Monday, then root A, root P A. Else response LBS. No go, or whatever. Right. So now if I have an API, previously I had my API. I can now do something like secreted. If not Monday, and then the server that I had before will work exactly as before, but I changed this little thing, and if it's not Monday, the server will behave as before. If it is Monday, then the server will disappear. We'll always return with no-go or 404 or whatever it is that you do, whatever it is that you do in this branch. So the cool thing is that everything that we wrote, all the combinators, everything was using this system, which is also available to people who don't have commit access to the GitHub repo, right? So the plugin system is the library. You know, usually very often with plugin systems, this is sort of like second citizen, second class thing. But we know this is not second class because that's how we did it. Yeah. But I don't know. So maybe I should probably wrap up. I feel I kind of wanted to mention a few things that that happened. I don't know, in the past week or 10 days or a month or so. What's been happening? There's a lot that's been happening. Yeah. Yeah.
Kind of summarizing statement on why you would want to endure this pain, which is part of what's happening here is that there are two languages.
Yeah.
There's a language at the Haskell type level that's allowing you to encode your specification. And there's a language at the implementation level, and the benefit you're getting is your implementation required by the type checker to be a valid instance of your specification. And because we have so much information about your specification now, we can generate default implementation in cases where you don't need any variance from the behavior. You get a lot for free. But that's why it's worth going through the pain, is to get that encoding of the specification as a code artifact that you work with.
Yes, and to your handlers have to do a lot less, basically, as well, right? Yeah, generally, there's so much information that your handlers have to do a lot less. And I also don't think it's pain. I know that everyone else does, but my sense is that after maybe it's different. But I don't know, because really when I look at the type level in Haskell, I'm very surprised at how it's not that different than like the abilities that you have in other languages, or the ability that you want in such a simple DSL. Right? In such a simple DSL, you don't want that much power.
And all the rest of us are looking at those and like, you're like, geez. Right. So we need what you know about how to read those error messages that ordinary humans.
But look, at least you're getting, like, so maybe the error messages aren't good, but at least you're getting them, right? So even if all you do is, as soon as you see an error message, just close your eyes and say, okay, it was wrong. Even if that's all you do about it, that's still better, right?
Yeah, can we have a prologue mode? No. Forever. No.
We're much more to have the error message, but you still have the error.
Yeah.
You get, it's better to have.
Oh no,
it
would 4 months later.
Yeah, exactly.
I can see prologue in production now.
Same exact problem.
Server down?
Yeah. So I think Julian means to say it's worth the pain until it becomes painless.
Yeah. But yeah, exactly. So this is different, and I'm aware of that, and it is painful initially. But I would reject the notion that it's intrinsically painful.
It's an incredibly painful way to do a very simple thing. It's a very not painful way to do a slightly more complicated.
Right. If you're ready,
Your data type has 3 variants.
Yeah.
And that's it, and you're done.
Yes.
This is a hideously painful way to do it.
Yeah. Yep. I agree. Well. Hideously.
If I need a different word, I'd be upset.
Yeah, exactly. If you have two or three endpoints and you know exactly, and that's all, then use Scotty. if once you sort of start seeing this like immense array of different things that you get out of it, this sort of then the story changes considerably, right? Like it's I mean it's basically the story like this. I feel like a lot of what people say and think about Haskell as well, right? Like it's maybe initially it actually is a little bit more difficult to write stuff, right? Or a lot more. But eventually.
Yeah, my language doesn't have maybe, we just have no.
That's fine. Yeah.
Let me ask you a slightly different question. What do you lose by moving an expression to that level? Relative to the value level?
Yeah. So for the library itself, it's hard sometimes. If you have the API description of the value level and the server itself at the value level as well, then you can you can have very nice data structures and you can rearrange everything very nicely. But so consider this. Consider the question of so let's use Ed's tagged. So let's D. So let's suppose that we had a list of actually, yeah. Let's suppose that we had a type level list of actually let's just stick with proxy. Proxy 5, proxy 2, and let's suppose that we wanted to sort the value level based on the type level. And so for each of these things, so we know that for each type level element in the type level list, we also have a value level one, which is very much what's going on in Servant. If we wanted to sort this based on the type level, it's painful because you have to do this in lockstep. So from my perspective, and I know this is probably the wrong perspective to first be taking when answering a question, but from my perspective, that's one of the most painful things. But from other people's perspective, I think like the tooling and the naturality with which it comes, right? It's not.
I guess I can give an honest, as someone who actually really likes it, I can give an honest answer about one of those.
Yeah.
It turns out that APIs in the wild don't accept all of your type serialized. The way you'd serialize it when you do again on it, as opposed to post on it, as opposed to put on it. So, for instance, you may have some object that you're manipulating via REST where you can't update its primary key ID. So the post won't let you change its, won't let you change your user ID. It won't let you change someone else's password, but you can change someone else's. So the way that you end up implementing your serialization for that type needs to be effectively different depending on whether you're posting it, getting it, putting it, or any number of other like things. Does that make sense? Right? And this has everything to do with the fact that the framework assumes that it knows how to put everything onto the wire because you've given it instances. Other frameworks will have this problem too, but it's really, really right here.
Yeah.
Where if you want to get any kind of reuse, like the CRUD example, you have, say, 20 different objects that you're CRUDing, right? Which is dirt simple intuitively. But if if it's like a Ruby, like a Rails API where everything has an ID column and you can change 0 of them, you have this problem where you need to be able to parse it out of the JSON when you do a get, but when you do a put to alter some of the things, you can't have the ID column in there at all because maybe it'll reject it because it's a read-only field. But maybe if you're posting it's that kind of thing, and having a to JSON and from JSON instance for a user is too coarse, but basically necessary to abstract. So I've been bugging have no idea.
Well,
Specify the API, the value level stuff like that.
You'd be writing your own serializers effectively, or you'd at least have control over how the serialization got done as a second pass, right? So you could serialize it to JSON, then yank the field.
yeah.
Because you got to sneak in the middle there, rather than having to rely on the code generator to eventually find the stuff you're doing and deserialize it at its leisure. And there may be some clever way to fix that problem, but it's what killed me.
What? Well, one of the sort of underlying problems there as well is that everything is based on instances, right?
Right.
So the level of granularity is much coarser than in the sense like
the interpretation of your data is based on a bunch of instances that don't always mean the same thing to the interpretation of the API.
Yeah.
You can do that.
No, actually, you can.
A number of things.
Let's say I want a CRUD combinator. That will say, here's a path, make me all the CRUD for this object. Now, actually, you need to say, now you need to give it not the types for, where the path is and just the type of the object, but also the type of the object we're putting, the type of the object when getting, the type of the object, right, and they're all different. What's this?
Reflection.
Yeah, thanks, Ed.
Wait, how would reflection?
Sucks.
How would reflection work?
You could make a data type, like a new type wrapper around whatever it is that has instances based on the reified type. So reflection lets you take a value level thing and make it into a type and reflect that down. And you can make instances that send that value to become available to your runtime.
Right.
You could reflect the sensor for the object in the different. Yeah,
exactly.
Thanks, Ed. Like the worst part about this is that I think you just solved my problem, and I'm going to have to go and do this, and that makes me really angry. God damn it.
Well, actually, yeah, this seems like a really interesting.
I know it was a serious suggestion.
Damn it! Why do you have to be right? Kidding, I'm a founding member.
Yes, but thanks. That was great.
It's worth it. I'll show you the other reflection trick later. That should be the takeaway.
There are lots of exciting things happening as well in the past few weeks and in the coming ones. 05 is coming out. We didn't even get to so 7 Hapsack just got released yesterday. So now we didn't get to the point the fact that you can nest Yeso and Scotty and whatnot within Servant, and vice versa, sort of. But now you can do that with Hapsack. Servant Snap, which Greg is working on, also does the same thing or will soon do the same thing with Snap. David Johnson is working on Servant Swagger, which is one of these description languages that I mentioned before. So now you can go into these other description languages. These are just new content types. This is a long story. We also Dennis refactored the stuff for client library generation, so that writing we have Elm, we have JavaScript in 3 different ways. We have Ruby, we have Haskell, we have PureScript client generators. But this refactoring makes it much easier to write client generators for new languages. So Elm's over there. Servant jQuery is becoming much nicer. You don't have to use just jQuery. You can use several other front-end frameworks. Auth is coming, hopefully soon. Faster routing is already merged, has been for a while, will be deployed. We have some HTTP error messages. You might have noticed that before when we got unsupported media type at some point in this presentation. That no longer happens in master. to sample no longer it has a generic instance and it doesn't have two arguments. The draw and enter, I didn't mention enter, but those things work together now. Cookies. Cookies. I have. Oh, you. Cookies. I have something that I've been using with cookies, but I never really released it. I should maybe. I didn't. Yeah. It was just like it was only like 4 or 5 lines of code, and I forgot about them. But I'll do that. Cloud Technologies has a servant client that compiles with JCJS, so you can use all the Haskell client stuff that I was using before in the front end. So verdict is the idea there is it's the same sort of like type level DSL idea, but for validation, the domain of validation. What I was noticing was that validation, and when you're validating the JSON that comes in, the HTML forms that come in, when you're all those are different. Like you're doing them in different ways. The different libraries that do those things. And when you have a smart constructor and a no fake type, you usually also do validation over there. And then your read instance, you have to be sure to do that as well. And in your database, there's also a description validation. Maybe the maximum length of a particular field is only 80 characters or whatever. And all these things are sort of related. And perhaps the original reason was JSON schema. It'd be nice to be able to generate JSON schema automatically for your, more or less automatically for your data types. Does it produce JSON errors?
Is that what happens if you request to send like a post request with a bad value?
Yeah. Currently, you just get the JSON errors, which are becoming significantly better. But now you'd get validation errors as well. So we finally are moving. This would be moving in the direction of HateOS, right? So you actually can do an options and actually see what the schema for the data type of the request body and the response body is. But it's getting big and complicated. It's growing in database. Verdict is also becoming a database of sorts. Not a database, on top, on top. An interesting database. It's interesting because you have your database data type, and the way in which you query the database is by the query function only takes one argument, which is the database. So the way in which you decide if you want, for instance, like a where clause where only people of age 32, where select person where person age equals 32, let's say. That equivalent in this verdict to be is just that your type basically says the person has to be of age 32. You just query and given the type.
In a set of objects.
Right, exactly.
Type level B tree.
No. The data structures are all in the value level.
What, you haven't done that yet?
But wherever, so it's definitely started off from like particular ideas about where someone should go, but I feel like I'm losing my particular ideas about where verdict should go. It's like this is becoming
Is verdict starting to approach overlap with Haskell?
Yes, it is. It is, but so definitely the sense that you get when or the sense that I get when looking at verdict is that it's like refinement types. But of course, it's not really like refinement types because the inference, basically the inference so like let's say that you have a function safehead that requires a list that's non-empty, and you have something that that has a list that has a length 10. That works with Verdict. It knows that length 10 it means that it's not empty. But the reason why it works is because you yourself describe fairly broad sort of logical connections between this DSL. So it's not so. There's only you have to be more explicit, and you can't get it wrong in theory. In theory, it could give you the wrong answer if you describe the inferences correctly. So there's only one place where you can get things wrong, but in theory you can get them wrong, right? Which is less powerful than assignment types. But I kind of need to update the examples as well because but yeah, but that's about it. There's some resources over here as well. I'll put this up. All this up. This is what I was mentioning before. This last one over here is the better version of what you asked for. I kind of wanted to give a sense of what it's like to actually use it, but yeah, but no. Sorry, just reflecting back on it. Do you have a couple more hours? But that's it. Yeah.